Hello, today I'm going to talk about Section 2.5, Solving Applications Involving Proportions. Now I'm going to start by reviewing some problem-solving steps that we have talked about in this class before, but relate them a little bit more to proportions. So let's take a look at the steps one by one. The first step, as is always going to be the case with any application problem, is you want to represent the unknown quantity with a variable. The second step is using the given information you have, set up a known ratio on the left side of your equation. Third, set up the other ratio using the variable and the other given quantity on the right side of the equation in the same position. And we'll take a look at that more carefully as we do the example. Finally, step 4, solve the equation by cross-multiplying. Again, that's something that you've practiced in your previous assignment. And last, don't forget you always want to answer the question being asked, and this means using the correct label. So let's take a look at an example and see how these steps will apply to that. So the example we have here is if there are 3 grams of solute in a 25 milliliter of solution, how many grams would be in 125 milliliters of this solution? So there's some given information, and there's also something that we don't know. It's the question being asked. So if you look carefully, the question being asked here is how many grams? That is what we are looking for. So when we look at representing the unknown quantity with the variable, we want to focus on that question. And so our first step here is going to be to let X represent the number of grams. So we clearly identify that by writing it down, and if you wanted to be even more precise, you could say the number of grams of solute, because that's what we were looking at right here, 3 grams of solute. So that's going to be what we're going to be asked to find here. Now, the second step tells us that we should use the given information to set up a known ratio on the left side. So if we carefully look at this first part of this application problem, you'll see that there's a known ratio that's given right here. We have 3 grams of solute for every 25 milliliters of solution. And so we want to be very careful here as we look at this that we are comparing right here the grams and right here the milliliters. That order is what's going to be important as we look at step 3 up above. Now in step 3, it tells me that I want to set up the other ratio using the variable and the other given quantity on the right side of the equation in the same position. Well, when I talk about the same position, I want to make sure my other ratio compares grams to milliliters just like this first ratio did. If I mix them up, I'm going to get a wrong answer. So you might notice now that I am given 25 milliliters of solution. I want to know how many grams are in the 125 milliliters of solution. So to set up my second ratio, I am putting the X, because that indicates the grams, that I want on top. So that's what I don't know. That's my variable. So I have X over 125. And so I've now just completed writing my proportion for this particular problem. So step 4 says let's solve this equation by cross-multiplying. So we talked about cross-multiplying yesterday. So I am looking at crossing over the equal sign and multiplying both of those crosses. Now, do you remember which one we start with first? That's right. We always want to use the cross that has the x in it. And so I end up with 25x is equal to 3 times 125. And 3 times 125 ends up being 375. So I now have 25x is equal to 375. To finish solving this, I simply divide both sides by 25, and I end up with x is equal to 15. And it's an exact 15. So the last step, if we go back up and look here, is after we've solved, we want to make sure we answer the question being asked, and we want to use the correct label. Well, if I've defined things carefully, my label is already in my definition for the variable, and so we said x was the number of grams, and so my final answer here would end up being that I need 15 grams of solute, if I wanted to be really precise, in order to create the same concentration in 125 milliliters of solution. So this is the end of the first example.